In contrast, hypothesis-driven science involves constructing a specific, testable explanation for a phenomenon based on a set of observations. After testing this explanation, conclusions can be drawn depending on whether the results you obtain support or refute the explanation. Hypothesis-driven science typically follows a series of steps, these steps here, called the scientific method. The scientific method is a loose set of guidelines for discovery intended to lead a scientist from an observation to an explanation. Have you ever eaten Peeps? It's just a sugary ball of sugar. My mother used to love Peeps. Loved them. An observation, what I'm getting at with Peeps, is that an observation is like noting a fact or an occurrence in the natural world. You're like, yeah, okay, that happens, that exists. You notice that here in the Northeast America, Peeps tend to get very abundant every year around April, and then they taper off a little bit and then reappear in October. This first observation, it doesn't lead you perfectly to a hypothesis. It might take a little bit more research. So more observations in the form of research are needed. You might incorporate some research from the natural world. Some animals reproduce on an annual basis. You might find out that animal populations will show an increase in number if they're counted, if they're reproducing. Observations typically lead to a hypothesis, many of them. And in this case, I could hypothesize that Peeps have an annual breeding cycle that correspond to temperature. Just work with me. So notice how my hypothesis, it's a statement. It's not a question. It's a statement. It answers a question. And also the hypothesis, my hypothesis has an expectation. It doesn't say the experiment will explore the breeding cycle and temperature. Oh, no, no, no. My hypothesis makes a prediction. It tells you what's going to happen when we explore the breeding cycle and temperature. Remember, we're not running screaming out into the playground here going, I'm going to explore. We have a direction. You are running out onto the playground headed for that one swing on the left, which is the only swing that has two lengths of chain that are equal. A hypothesis is a testable explanation for an observation. It's important to note that a hypothesis, it's not like a shot in the dark, right? You're not like, ah! It's based on prior knowledge, a couple pieces of prior knowledge, a few. Hypotheses are stated, they're never asked, they're not a question. They're statements. Peeps breed more with increased temperature. And this leads to a very specific prediction, namely, if I go to a local peep breeding ground, such as my local Walmart, I will see an increase in the peep population as the temperature rises in the spring. Again, I know, ridiculous, just keep working with me. It's important to remember that a hypothesis, it has to be testable. It can't be like, and I hope this happens, right? This can be kind of tough when we're considering the natural world, right? A testable hypothesis. And this is why hypothesis-driven science usually takes place in a lab. These investigations have to be really controlled, really managed carefully in order to proceed as expected. And this is what hypothesis-driven science is. And we do this in this class. You are not groundbreaking in this class. You are testing things that we already know. I want to bring up something really important here. Hypotheses don't have to be correct, especially in this class. You can be wrong. You can be wrong all the time. It's all right. You will often be wrong in this class. Experiments fail, especially experiments you've done for the first time, whether you're doing it with the instructor in class or whether you're doing it by yourself at home. And it is okay. What is important is your ability to explain how your results don't support what you expected, or how your results did support what you expected. It's all right if you were wrong. Knowing that you were wrong is the most important thing. If the data that you generate this semester ever doesn't support what you thought, that is perfectly okay. Your hypothesis, it wasn't a shot in the dark, right? Based on research, you thought it was going to be true. But your experiment, it's only one test of a hypothesis. So you're allowed to get it wrong. And you're allowed to say why and how you know that you got it wrong.